Here in this one, let's say there was a word problem involved. It's just they went ahead and already gave you all the inequalities. We've got x plus y is less than or equal to 4, 2x plus y is less than or equal to 5, and we're going to be graphing in quadrant 1, that xy is greater than 0. And then they already went ahead and gave us our equation that we want to maximize. The equation we want to maximize looks like it's a p equal, so maybe it had to do something with profit or something like that. All right, like I said, take each of those equations, and this time, instead of specifically, we want to find our x and y intercepts off of those. So to find the x-intercept, just cover up the y. So our x-intercept will be x equals 4. Our y-intercept will be y equals 4. So there's our x-intercept, and there's our y-intercept. Remember, you know how to find an x-intercept, you let y be 0. And how to find a y-intercept, you let your x be 0. So just plug 0 in for each case. All right, let's go to the next one. We have 2x plus y is equal to, or less than or equal to 5. Okay, if I want to graph that for my x-intercept, then I'm going to cover up the y, because the y is going to go to 0, and you'll get x to equal 5/2. And then for my y-intercept, then the x is going to go away, so that takes all the 2x gone, and it'll just say y is equal to 5. All right, and then last but not least, from there, we just know that we're going to be graphing in quadrant 1. Okay, let's form the graph then. It looks like we're going to go anywhere, the highest we're going to get is 5. So let me do these in different colors so we can kind of pay attention. I'll let this first one be in purple. We're going to go from 4 to 4. 1, 2, 3, 4. And solid line, so I'm going to connect it. And notice how when I connect it, I'm just going to stay here in quadrant 1, because like I said, we're only focused here in quadrant 1. All right, and what it's saying is I want to be able to add up two values, an x value and a y value, and still stay smaller than 4. So let's pretend we're going to test. Let's test 1 and 1 right there, that 0.11. Is 1 plus 1 less than 4? It sure is. So I'm going to be shading down towards that test point. If you wanted to test another point, let's say 1, 2, right there. Is 1 plus 2, is the x value plus the y value still less than 4? It sure is. So that kind of shows you right there. And notice how, again, with that shading, I even kept it in quadrant 1, because this whole x plus y, or x and y greater than or equal to 0 is telling me to keep it in quadrant 1. Okay, so let's get another graph going on here. Let's do green. How about for the second line? It has an x-intercept of 2.5. 1, 2.5. It has a y-intercept up at 5. So let's connect the dots right about there. Okay, going back to the original equation, I need to take 2 times an x value and add a y value and still be smaller than 5. Well, let's say I test it again. Let's say we want to test 1, 1 again. Notice that point right there. Is 2 times 1 plus 1 still less than 5? Well, 2 plus 1 is 3. That's less than 5. So I want to make sure from that green line that I am shading down towards the x-axis and the y-axis. Okay, so here, let's make this a little bit darker. What's our overlap shaded region? Where do both the purple and the green occur? Well, it looks like it's going to be everything below the y-intercept of 4. It's going to come right into here. It's going to curve down and come right in here. So it looks like this is the overlap shaded region right there. So now that we have that, let's list off our corner points. Okay, our corner points. We obviously have this y-intercept right there in that corner, and that's 0, 1, 2, 3. That's 0, 4. Okay, we have another y-intercept, or we have another corner point 0, 0, which is that bottom corner. We have one right here that's at 3, 0. I'm sorry, 1, 2.5, 0. And last but not least, we have a corner point right here, the intersection. We need to be able to find the intersection of these two. So let's go back. Let me show you. I'm going to do some work up here on how we're going to find the intersection point. Let's take those two equations. I'm going to write them in just equations. So x plus y equals 4 and 2x plus y equals 5. If I gave you those two equations right there and I said find out where they're going to intersect, you either can do substitution, elimination, or matrices. Obviously, I can pull out a calculator real quick and do a matrix. But just notice this. The y's match up to a t, one y and one y. If I just go through and I subtract, it's going to eliminate my y's. So I can real quick do an elimination method. See, 1x minus 2x's is a negative x. Y minus y is 0. And 4 minus 5 is a negative 1. Divided through, so x is equal to 1. To get the y value, just go back to, let's say, that first equation where I have, x plus y equals 4. So 1 plus y is equal to 4, or y is equal to 3. There you go. There's our last corner point. It has an x value of 1 and a y value of 3. And you know what? I did a pretty good job of graphing. That kind of looks like it 1, 3, but never, ever trust your judgment, ever. You always want to go and, because who can graph perfectly, honestly? Okay, you're always going to want to go back and find that. Okay, so far what we've done is we've graphed all of our inequalities. We used our intercepts to do it. We found all the corner points. So lastly, all we want to do now is go up to our profit, or our equation that we want to maximize, which in this case is P, and we're going to plug our corner points into the equation. So it says x plus 2 times my y's. X plus 2 times y. X, so I'll say 2.5, plus 2 times my y. And x plus 2 times my y. So there's 8, 0, 2.5, and 6. Well, the maximum value right there comes at 0.4 right there. So wasn't really necessarily at it was close to be, it was worth finding that fourth corner point. It was worth it to find that intersection because it was close. It could have potentially been that, but we didn't know. So like in this problem, this is going to be an interesting one because look, the max happens when you have 0 of one thing and 4 of another. So if X was the number of t-shirts and Y was the number of caps, what it's telling you is in order to maximize your profits, you don't want to sell any t-shirts. You want to go solely for caps. It's kind of an interesting thing to look at, but hopefully you are kind of get an idea of how to work on these problems. So let's go try this one more time. Let's go to example number 9. And with this example, we're going to do exactly the same steps we did before. Start with all of our inequalities, and we're going to want to find their intercepts. So 2x plus y is less than or equal to 6. So for the x-intercept, just cover up the y's. And then, so it says 2x equals 6 or x equals 3. For the y-intercept, we're going to cover up the x's. So if the x's go away, you'll just get y equals 6. All right, on the next one, we have x plus y is less than or equal to 4. So if I cover for the x's, if I cover up the y's, you'll get x equals 4, and then y equals 4. If I wanted to graph x is less than or equal to -1, that right there is just a vertical line, right? Because anytime you have an inequality or an equation, it just has one variable in it. You're either doing a vertical or horizontal line. If that one variable is an x, then you're talking specifically about a vertical line, and if that one variable is a y, you're talking specifically about a horizontal line. All right, so we can get our graph going here. We're going to focus in quadrant 1 again. That's the whole x and y is both greater than or equal to 0. Get some lines drawn on here. Okay. And let's start connecting some of these dots together. Let's do purple for that first line. I have an x-intercept at 3, a y-intercept at 6, and solid line. And looking at it, I want to take 2 times my x value, add on a y value, but still be smaller than 6. Well, let's test 1, 1. It's 2 times 1, so 2 plus 1 less than 6. Looks good. So again, I'm just going to be doing this just right down to the origin. So I don't really need to go anywhere outside of quadrant 1. Not necessary. All right, let's go to the second line here. I'll do that one in green. We have a y-intercept and an x-intercept both at 4. Can do a solid line through there again. All right, and on that one, we want to be able to add 2 values and still stay within 4. So obviously we're going to want to shade down towards the origin because we want to shade over that point like 1, 1, because 1 plus 1 is definitely smaller than 4. And if we do that next line says I want all these x values to be smaller than 1. Okay, so less than 1, here's that vertical line kind of happening right here at 1. So all the x values smaller than that, but still staying in quadrant 1, it's kind of coming in right here. Okay, let's get out a darker color and see what we can come up with this. So I need an area where both the orange or the red, the purple, and the green all overlap. So it looks like we're going to start right up here at that x or that y-intercept. We're going to come down to here, got something going right there, coming down to there and there. So it's going to be all in this region right in there. Okay, let's list out those corner points then, see what we can find, and if we have to go do some more math to figure it out. Looks like that top left one is going to be 0, 4. It looks like we still have 0, 0 as the origin. We have an x-intercept at 1, 0. So all we need to do is find that one corner point right there. And let's figure out, we've got some options. Where was it? Well, it was the intersection of the vertical line. So it was the intersection of that vertical line of basically x equals 1, and then it was the intersection of that green line, and that green line was x plus y equals 4. So it really has nothing to do with that purple one. Okay, well let's see, how can I solve those together to get an actual coordinate for it? Well, we're pretty much halfway there, because it tells you, first of all, x has to be 1. That checks that off. So if x is 1, what's the only thing you can add to 1 and get 4? Well, y has to be 3. So there's my next point, 1, 3. And hey, it looks pretty good right there on the graph. All right, let's go up to our main P equation and plug it in. X value plus 3 times the y value for each one of these. So the x value and 3 times the y. Oops, x value, which is 1, plus 3 times the y. All right, this time we want to maximize, so we're going to look for the highest point, or the highest value. 4 times 3 is 12, 0, 1, 9, 10. So it looks like, again, it's happening up at that y-intercept. Don't always expect that to happen. A lot of times when we get to the word problems, it's actually coming at the intersection points. So we're going to have a max. And sometimes if you look in the way they word these, by the way, in the book, it might say the max of 12 at 0, 4. Okay, might say something like that to get a little technical. But let's go on to the next example.